Here's the last rule that was from yesterday that we didn't really talk about. So we talked about making sure that you'd have any perfect roots. Actually, no, we only talked mainly about that one. I take that back. We're going to cover the last two rules today. The second rule was that you cannot have a fraction as a radicand. And remember, your radicand means the expression underneath the radical. So remember, quotient rule really means if you have the square root of a over the b, it really means the square root of a divided by the square root of b. You just take each square root separately. Now, just like yesterday, we're still going to have to break these down. Okay? So if I go to this first one that says simplify, the square root of 35 and the square root of 15. Sorry, the square root of 35 fifteenths. What do you think you should do first here?
Simplify.
I would simplify it first. What divides out of both?
5.
Because they're both underneath the square root, we can divide a 5 out of both. 7. 12 twos!
7 3.
Okay. I like it. Now what? I should separate them. The square root of 7 divided by the square root of 3. Now here's the deal. You cannot have a square root in the denominator. Everything we've done thus far is correct. So the easiest way to get rid of the square root of the or to get rid of that square root in the denominator is to multiply that to the top and bottom. So I'm going to multiply by the square root of 3 to the top and the bottom. That seems like a really strange thing to do, but I'm going to show you why. What is the square root of 7 times the square root of 3? Square root of 21. What is the square root of 3 times the square root of 3?
9.
The square root of 9. What is the square root of 9? Is 3. So you end up with the square root of 21 divided by 3. Now, can I cancel 21 and 3?
Yeah. 7.
Why not?
They're not
21 is in the square root. 3 is not.
So that's it.
So that is it. Other than, you always got to make sure if you can break 21 down, but the only thing that multiplies into 21 is 3 and 7. So if you can simplify first, that's going to save you some time. So how?
What do you mean break 21 down?
So like say you had the square root of 30 up here, and you could break it down 3 and 10, 2 and 5, and you had like 2 of the same number to break it out front. You know what I'm saying? But you can't simplify that radical though. The square root of 6y divided by the square root of 12.
Divide by 3.
We could divide by 6, right? I mean, technically you could divide by 3, but you could go further. So I'd end up with the square root of y divided by 2, which then we can split up, right? So the square root of y divided by the square root of 2. Can I quit here? What do I do? Multiply by the square root of 2. On the top, I end up with square root of 2y. On the bottom, technically the square root of 4, which then really simplifies to be 2. Can I simplify the 2's? No. The one on the top is in a square root. The one on the bottom is not. Try that last one on your own. Is that what you wanted me to do? I put 2. I don't know what I was thinking. Hi, Mrs. Weber. We all awkwardly turned and looked at her. We probably should say hello. How kind of you.
Skip said his best he'll teacher.
All right, here we go. So I have the square root of 9 and the square root of 2, which is really what? 3 and the square root of 2. Now what do I do? We'd have to multiply by. Don't erase what you have. Don't erase what you have. You might not be wrong. You'd end up with 3 times the square root of 2 divided by 2. My guess is you guys right here, square root of 9 and square root of 2, you went times the square root of 2 and times the square root of 2, right? So what'd you end up with? 2, right? This is what I mean by you can't quit here. Because 18, you can factor out to be 3 and 6, 2 and 3, right? You have 2 3s, you write it down one time outside, and you have that square root of 2. This is why as you go, anything you can simplify, I think we all agree the one on the top seems like less work. Anything you can simplify along the way is going to make your life that much easier. Okay? So to get the square root out from underneath that radical, you put the square root on the top and the bottom, but you cannot end with that square root on the bottom. So the second piece of today is binomials. Remember, 2 terms in the form a times the square root of b plus c times the square root of d, or a times the square root of b minus c times the square root of d. This seems really confusing. You either have a plus or a minus. That's what separates your 2 terms. And so you have a binomial that has some type of square root in it. Look down here. 5 plus the square root of 2. That's a binomial that we're talking about. Okay? These are called conjugates. So you have a binomial, 2 terms that are either added or subtracted, that include a radical. Okay? And they're called conjugates because if you look, they're opposite signs. Do you see that? 2 plus the square root of 7, 2 minus the square root of 7. Those 2 binomials together are called conjugates. The product, what does product mean in math? Multiply. If you multiply 2 conjugates, you get a rational number, aka no square root. Okay? So if you end up with a fraction that has a binomial in it, we don't want to leave the square root in the denominator. We can't leave the square root in the denominator. So to get rid of this, we multiply by the conjugate. The difference is, it is a plus right now. We're going to change it to a minus. So we are going to multiply by 5 minus the square root of 2. But you guys know the rules with fractions. Whatever you do to one side, you have to do the other. So I got to multiply the top by 5 times the square root of 2 as well. Or 5 minus the square root of 2, sorry. So we take our number out front, 3, and we distribute it. 3 times 5, 15. 3 times a negative square root of 2. Can you multiply 3 and 2 together? It'd be negative 3 square root of 2. Why can't you? Very good. They're not both in the square root. Okay, now remember our rules back from chapter 8. Everything in the first binomial has to multiply by everything in the second binomial. 5 times 5, 25. 5 times negative square root 2. Negative 5 square root 2. Square root of 2 times 5. So positive 5 square root 2. Negative square root 2 times square root 2. Rude. What'd you say? Negative square root of 4. Now this seems super confusing. Why is it not though? The middle terms cancel. Do you see that? One's a negative and one's a positive. So this cancels out. 25 minus, what's the square root of 4? 2. So really this is 15 minus 3 square root 2 divided by, which is 23. The whole purpose of this is we cannot have a square root in the denominator. When it's just a single term, just the square root, we multiply by that. When it's a binomial, we multiply by the conjugate. Every time that denominator should end up being a single number. In the middle, what should I multiply by? 2 minus the square root of 2, both on the top and on the bottom. Okay? On the top, distribute. Please share your answers. 6 minus 3 square root of 2. Okay? Who wants the bottom?
I do.
Mason's on it.
4
4.
minus 2 to the square root of 2
Okay?
plus 2 to the square root of 2
Okay?
minus square root of 4.
Agree or disagree with him?
Agree.
Good work. What happens?
Middle.
Middle terms cancel. So really I have 4 minus 2, right? So I have 6 minus 3 square root 2 divided by 2. And I'm going to tell you they're going to count this wrong.
6 and 3. It's a minus 7.
Oh, just kidding. Never mind. They're not going to count it wrong. Ignore me.
Don't you want to do 6 minus 3 to get 3?
Do you want to do 6 minus 3?
No.
Why not?
Once you have to do that first.
3 is multiplied by the square root of 2.
Oh.
So it's really like 6 minus 3x. If you think of it that way, you know what I'm saying? Oh, Nellies. How do we do this last one?
Same thing. That's 2 square root.
Okay, so what am I going to multiply by, Sassy? Yeah, square root of 7 minus the square root of 3. Only change that middle sign. Mason can't answer. Somebody distribute on the top for me.
Square root of, I mean, no, 5 times square root of 7. No, 5 to the square root of 7.
Yep.
Minus 5 to the square root of 3.
Good. Who's got the bottom? Thatcher.
Square root of 49 minus square root of 21 plus square root of 21 minus square root of 9.
Agree or disagree? Nicely done. Do my middle terms cancel like they're supposed to? Okay, now what do I have on the bottom, really? 7 minus 3. So I have 5 square root 7 minus 5 square root 3 all over 4.
Can you like minus that to make it a square root of 4 and then just put it to 2?
No. Okay, so that's a really good question. Like I was explaining to her, a square root of 7 and a square root of 3 are like 2 different variables. So it's really like having 5x minus. Guys, Thatcher just asked a really good question, and none of you have any clue because you have your laptops open and not on your calculator like you're supposed to. He said, why couldn't you just subtract the square root of 7 and the square root of 3? These square roots are different. So they're almost like, I always think about them as in variable terms. 5x minus 5y, could we combine those?
No.
No. So square root of 7 and square root of 3, we cannot combine. That's actually what we're going to work on tomorrow, is when you can add and subtract them. Okay, you for sure are going to have work to show today, so please get work paper and go ahead and get started.